Okay, so we've got a particle on a slope. It's held at rest. And they've got the angle there is sine to the -1 of 4/7. And it's released and moves down the plane. And so it's going to be accelerating down the plane. And v is velocity, that's v. And it's accelerating down the plane there. Force is active on it. Obviously we've got the mass of it, which is mg. We've got the normal contact force, which is r. And we've got this resistance to motion. It's not the same. It's going to increase as velocity increases. That's 0.2 mv, and that's the total resistance acting it. And we've got to show that we've got this. And dv by dt, that is a. So that bit there is a. And so we're going to have to find, and then we're going to have to get this, and we're going to have to find v in terms of t. So the first thing we're going to do, we've got to get that. So we're going to resolve down the slope, and we're going to get resultant force equals mass times acceleration. If I split the force of the weight up, we get that and that bit. So what goes down the slope? We've got this part here, so that will be mg sine theta, and that will be sine of sine to -1 will be, that'll vaporize these other, they're inverse operations, so it'll be mg times by 4/7 minus 0.2 mv, and that's our two forces, and that will equal the mass times by the acceleration, which is dv by dt, because that's what we wanted it by. Don't forget, you could occasionally have a equals v dv by dx, and sometimes we want that, but in this case we don't need that. We got it here. I'm going to write this around the other way around, or I can get rid of the m's, can't I? And so I'm going to get dv by dt equals 4/7 g minus 0.2 v, and it's close to what we've got here, but that's 5.6, so dv by dt equals 5.6 minus 0.2 v, and it says minus v, so I'm going to have to times that through by 5, and that'll give me 5 dv by dt equals 28 minus v, and that's what's wanted. So quod erat demonstrandum. And now we've got to find v in terms of t. So we're going to have to solve this differential equation. So first thing I'm going to do is, first thing I'm going to do is to separate the variables. And I want to have all the v bits over here and the t bits over here. So I'm going to divide everything through by 28 minus v. So I get 5 over 28 minus v dv, and times both sides by dt, so that'll give me dt. That means, and it's basically I'm integrating both sides with respect to t, so I'm going to put the integral signs in there and then put 1 in there. And this bit's not quite what I wanted it to be, because it's close to being a ln, but I need the top to be -1 if I'm going to make that the case. So what I'm going to do is I'm going to change that one, I'll do it in purple, change that to -1, but therefore I'm going to have -5 lots of them to make sure I end up with having 5 is what I had initially. So I need to get -5 lots of that, and that bit is going to come all the way up here. And so what have I got? I'm going to integrate this, so I'm going to get -5, and now I've got, so if I differentiate the bottom bit, I get the top bit, so that's just ln of the bottom bits. So ln of 28 minus v, and that equals, or let's put the plus c, I'm going to put the plus c on that side, and that equals t. And when t equals 0, v equals 0, therefore -5 ln 28 plus c equals 0, so c equals 5 ln 28, and so we get -5 ln 28 minus v plus 5 so I spell 5 ln 28, that equals t. But it's not good enough because I need v equals. So I need to get this so I get v equals. And the first thing I'm going to do is I'm going to divide through by -5. And that will give me ln of 28 minus v minus ln of 28 equals minus t over 5. I've got a ln, subtract a ln, so that's the same as the ln of the quotient. So I get ln of 28 minus v over 28 equals minus t over 5. I want to get rid of the ln, so I have to do the inverse operation, so I'm going to do e it, and that gives me 28 minus v over 28 equals e to the minus t over 5 times by 28. So 28 minus v equals 28 e to the minus t over 5. And now I'm going to add v to this side. So I'll just bring that round to here. So I get plus v there. Let's get rid of it there. And then take away that. So I'm going to get v equals this bit here, 28 minus 28 e to the minus t over 5. Or I could take out v. I take out 28. 1 minus e to the minus t over 5. And that's done. Find out what v is. And now I've got a tiny bit of space up here to do. I'll do this bit in purple. I've got to find the acceleration of p when t equals 10. So this is part 2. So when t equals 10. Well, this is my formula for acceleration. So that's a, which equals dv by dt. All I need to do is find out what v is, and if I find out what v is, then I'll be able to work out what acceleration is. So I've got to find v when t equals 10. So when t equals 10, v equals, well, it's straight in from here, v equals 28 times 1 minus e to the minus 2. And so v equals 24.21. And now I can sub this into the one I had over here. Where was this one over here? So a equals 5.6 minus 0.2 times by 24.21. And so a equals 0.758 meters per second squared. And that's 4 done.